So we've done inequalities, we've done systems of equations, now we have systems of inequalities. That's what's going on. So understanding these symbols, the first one is an equal sign. What does that line look like? Solid or dashed? Solid. What's the next symbol? Less than. What's that going to be? Dashed. Next one. And it is? Next one. And it is? Solid. Who's calling me? Last one is what?
Oh, it's more than or equal to.
More than or equal to or greater than or equal to, yeah.
That's
Same thing. And it's going to be what kind of line?
Solid.
Solid.
Yeah.
Solid. Good. Sweet. Okay. We are going to graph systems of linear inequalities, which means the same rules apply as graphing equations, okay? So same as graphing equations. But what do inequalities have that equations don't have? What did we have to do on the test? Shade. So, but with shading. You hate shading? Why? Shading and dotted or solid lines. Okay. Now we've got some steps. Not as much writing as last class, but we do need to write these down. First thing is just to solve both inequalities for y. Solve both of them for y. Then we are going to graph one line and shade it lightly in pencil. So if you don't have pencil, you're going to need to borrow one. Keyword is lightly. Don't dark shade it, because then it's going to be hard to go back and erase, which is what we have to do. Okay, if it is less than or greater than, what kind of line is it? Dashed. And if it is less than or equal to, greater than or equal to, it's solid. Yes, yes, yes. Okay. Next thing you're going to do is pick a point that is within the shading. And check that it's a true statement, or check that it works. I'll show you what that means in a minute. Repeat for the other inequalities. So that is repeat all of these steps. Your final answer is just going to be what shading they have in common. Which means you're going to need to erase some things. Gonna have to erase. That's why we've got to shade these pretty light. Whoops, sorry. We got to shade these pretty light. Anybody not have a pencil today? Okay. All right. So, very first one. Are both of these in y equals, or sorry, y on one side? Yes. So I'm able to go ahead and start graphing. So we'll start with the first line. Y is greater than or equal to negative x. What should I do first? How would I graph that? Up one, left one? That works, but what's my b value here? Isn't that where we always start on these? 0. Good. And you can go up one, left one, or down one, right one, right? Either way. But I'm going to graph this whole line. Okay, let's see. Ooh. It was okay. Not the straightest line I've ever drawn. Okay. Now, we've got to go ahead and shade for this one. So if it's y is greater than this line, go to your y-axis, and which side is y going to be greater? Going up, right? These are the y values bigger than that line. So that means I'm shading this whole side of the line. Shade lightly. Shade so light. Okay. Now we got to graph the second line. Y is greater than or equal to x. What would be the b value?
0.
Yep, still 0. My slope. Up one, right one, which it's good that I shaded light so I can see where I'm putting my points. Is this going to be a solid or a dashed line? Solid again. Okay. Now it's y is greater than that line, which means what?
Shade right.
So shade above that line where y is greater than, right? So I'm going to go ahead and I'm only going to shade what that shading has in common with the other, okay? You could go ahead and shade this whole side of the line, but then you'd know that you have to go back and erase this part. Okay, and then what else do I need to erase?
That bottom one.
This right here, right?
Sure.
Not the line. Don't erase the lines, just the shading. So we only need the shading that they have in common. You with me? Last thing I want to do, I just need to find a coordinate point that's within that shading. It could be any coordinate point. So anything that's in this region.
Up forward, left fold. Or up forward, left fold.
So in both regions,
Yeah.
1, 1, is that what you said? That works. So I'm going to go and I'm going to put in the point 1, 1 to both of these inequalities. So for the first one, y is greater than negative x. Is 1 greater than or equal to negative 1? Is that true?
Yeah.
Yep. And then for the second one, is 1 greater than or equal to 1?
Yeah.
Yep, so I did it right. Okay, so you just pick a point and make sure it works for both.
But if it's not straight now.
Then you probably did something wrong and you need to go back and look. Yep, good question. If it doesn't work, you either picked a wrong point that wasn't in both, or you did something wrong. Okay. Yes.
Can you wait till the end, like once you apply your lines to shade?
You can. Yep. Then that's a good question. If you want to wait to do the shading because you don't want to have to go back and erase, that is fine. Just make sure that you do that correctly and you don't get confused. Good question. Okay. Number 2. Is that second one, is that in a form that I can graph? No. What do I need to do?
Bring that 3y over.
Bring the y over? So I need y on one side. Yep, bring the 2x over. So 3y is less than or equal to 2x plus 6. And now I need to divide everything by 3. Y is less than or equal to
2 over 3x plus
Perfect. 2/3 x plus 2. So now I've got my two equations. Okay, I'm just going to cross out my work just so I don't get confused and try to graph anything like that. So I've got my first equation, second equation. Am I ready to start graphing?
Yep.
Yep. So on the first one, my b value is, what'd you say? What kind of 2? The first one. -2. The slope is up 1 over 2 or down 1 and left 2. What kind of line is this going to be?
Dotted.
Yep, dotted or dashed. Make sure you pay attention to that. A lot of us missed that on the test.
Yeah, I just missed that myself.
This is y is greater than this line, which means that I need to lightly shade. If y is greater, above or below? Above. Shade the y values above and lightly shade this whole line. Above. Next one. B value. 2. Slope. Up 2 over 3. Or down 2 left 3. What kind of line is this one going to be?
Solid.
Solid. And this one is y is less than or equal to, which means above or below this line?
Below.
Below. So what do I need to erase?
The top shade.
The top shading.
I ain't doing it right. Let's go.
Okay. Questions on that? Got that down, Aiden? Got it, Dominic? Why does it sound like a baby is crying?
It's one of those robot babies from parenting.
3 and 4, please work on these with somebody around you. We'll go over them in about 2-ish minutes, maybe 3. Okay, let's look at these. So, first problem, number 3. Are these in a form I can graph? Yep, they are. So let's go ahead and just graph the first one. Y is greater than or equal to 2x plus 1. What should I do? Plot a point on 1 and then up 2, right 1. Or down 2, left 1. And what kind of line is this going to be? Solid. Raise your hand if you agree with that. You should. Okay. Shading above or below this line. Y is greater than, which means I'm shading above. So again, guys, if you decide to use this method instead of waiting till the end, please make sure you shade lightly. Y is less than -x plus 4. What should we do there? Plot a point on 4 and down 1 over 1. Or up 1, left 1, right? Gonna look like that. And then it's y is less than, which means I need to shade below this line. So I only need to shade what it has in common with the other shading, which is going to be this portion, correct? What do I need to erase? Yep, this little part right here. Any questions on that?
Nope.
Okay. Number 4. This is a fun one. First one is y is less than or equal to 1/4 x minus 1.
I did not do that.
You didn't know how to do that?
I just erased all of 4 and we were just doing 3.
Why? One thing we forgot to do on number 3 was plug in a point. Let's do that real quick.
I forgot to do that on 2 as well.
I forgot to do that on 2 as well. You can go back and do it. What's a point that's within both of these shadings? Anything. 2, -1. That would be right
No.
here.
Maybe
-2, 1. Okay, so right here. Let's try that. So -2, 1. Plug it into the first one. So x is -2, y is 1. So 1 is greater than or equal to 2 times -2 plus 1. What's 2 times -2 plus 1? -4 plus 1 is -3. Is 1 greater than -3? Greater than or equal to? Yep. And then the second one, plug it into this. 1 is less than -2 plus 4. What's a -2? Is 1 less than 6? Yep. So that one checks out too. Okay. Now number 4. How would I start this? The b value is good. And the slope? Up 1/4. We are pros at graphing lines now, aren't we? Dashed or solid line?
See, yeah, I knew.
You knew? Y is less or greater than this line?
Greater than.
What?
Less than.
Less than, because it is a less than sign, which means it's these values below. So shade lightly. Y is less than 4. Is this a hoy or a vux? What?
Or whatever it's called. It's not
A hoy? Yep. It starts with a Y, so it's a hoy. What's the H in hoy stand for? Horizontal. So this should be a horizontal line on the point where Y, on your Y-axis, where Y is on 4. Dashed or solid line? Dashed line. That is horizontal. Should look just like that. And it's Y is less than or Y is greater than? Less than. So should I start shading this? And below? Do I need that part though? No, what do I just need?
blue.
Yep, just the blue. Because they both have that in common. Cool. Cool, cool, cool. Questions?
You need a point.
What?
Never mind. It's like I didn't say.
Okay. Awkward. Last 2 here. Are these the last 2? Last 2 graphing? Okay. Go ahead and try these with the partner as well. All right, so first one, is that in a form that I can graph? No. Okay, let's see here. How do I get this in a form I can graph? Subtract the 4x, good. So 3y is greater than -4x plus 12. Are we all with me? Yep. Then what? Divide by 3. Good deal. Carson's first day, and he's already participating more than over 70% of you. Thank you, Carson.
Some days.
So y is greater than Negative 4x divided by 3 is going to be 4/3 x. Negative 4/3 x and plus 4. And my second equation, is that in graphing form? Yeah, so it just stays the same. Anthony just said, so they're basically the same line. Are they the same line though? They're going to be parallel. How do you know that? Yep, same slope, same rise over run, but different b values, different y-intercepts. Good. So the first one's got a y-intercept of 4. The slope is down 4, right 3. Or up 4 and?
Left 3.
Yep. And it's going to be a dashed or a solid line. Dashed. And its x is what? Greater. So I would shade this way. I shall. Next one. Same slope but different b value. So I'm at 1 now instead. Still going down 4, right 3. Yep. Still a dashed line. Its y is what? Less than, which means I'm shading up or down? Down. Do these have any shading in common? Because remember, we said the answer was going to be what they had in common.
False.
Not false, but no solution. Good. This is a no solution. If they have no shading in common, it's just a no solution. You can write out the words, or what does that little symbol look like?
0 with a crossover through.
Yep, just like that. Slanted line up through it. You're welcome to write that. Word. Last one. Last graphing one. Ooh, yay. You already done with that one? Look at you, overachiever. X is greater than 2. What we got? Is it a hoy or a vux? A vux.
I guessed it. Why'd you guess it?
I wasn't looking.
If it is x is greater than 2, that tells me, where am I putting a point?
On the right side of 2. So like closer to 2.
On the x-axis on 2?
Yeah.
And it's going to be vertical or horizontal? Vertical, because it's a vux. Dashed or solid?
Dash.
Greater than or less than? Greater than, which means I'm shading
Right.
to the right. Next one. Is that in graphing form?
Yes.
Yep. B value is
Negative.
-1.
slope.
-2 over 1.
Down 2 over 1, down 2 over 1, down 2 over 1, or up 2, left 1. Dashed or solid? Dash line or a solid line?
Solid.
Solid.
Sleepy.
Okay.
Whoa.
That escalated quickly.
Oh.
Less than or greater than? What? Less than or greater than? What we got?
I look at my notes. Oh no, my homework.
Less than, which means I'm shading down. Okay, be really careful on this one. This one's kind of a tricky one, okay? If I start shading down, I would shade all of this, but what do they have in common? It's kind of a small area. Do we see it?
Yeah, I see it.
Right here? It's kind of like triangle. That's all that those two have in common. Nothing else. Which is why it's good if I shaded lightly, because I got a lot of erasing to do on this one. Does everybody see how that one worked? Okay, let's check this one just because we want to be sure. What's a coordinate point that would fall in that region? Let's look. Looks like if I went,
8, 4,
what'd you say?
negative 8, 4.
Okay, I heard negative 8, 4, which would be right here.
Negative 5, 2.
Negative 5, 2 would be right here, Zach.
Yeah, that's
Or
way
sorry.
over.
Yeah, that's what I meant.
Yeah,
Negative 5.
see, we're saying it backwards.
2, negative 5. Okay. I'm actually, since one of those lines is dotted, I'm going to go a little bit further down. I liked Anthony's line better. He did 3, negative 8. Let's do that. 4, negative 8 would be right here, though. Be outside. So let's just do 3, negative 8. So this is x, this is y. Is 3 greater than 2? Yep, because I just plugged that in to this equation. 3 is greater than 2. Then I've got y, which I said was negative 8. Is that less than or equal to negative 2 times 3 minus 1? What's negative 2 times 3? Negative 6 minus 1. So is negative 8 less than or equal to negative 7?
Yes.
Yes, it is.
I don't like negatives, okay? They scare me and I hate them.
Don't let them scare you.
32.
They're not vampires. Even though it's spooky season. Okay, let's go here. Are the following points a solution to the system? Okay, these are really easy. These are just checking the points like what we did with our checking the solution one. Okay, except we don't even have to find the point on the graph. They're just giving us a point. So all I've got to do, plug both those points in. This is going to be 2 different problems here. Plug them both in, see if they work. So we'll start with negative 2, 4. Which one's x?
Negative 2.
Which one's y?
4.
So I'm going to plug it into both of those equations. So if the first one would just be,
Can we do both of them?
because it's a system.
Well, I plugged in like each point with each equation. So, kind of messed that up.
Okay? So negative 2 plus 4 times 4, is it greater than or equal to 6? Negative 2 plus 16, is that greater than or equal to 6? Yep. Now I gotta check the other equation. So 3 times, what is x? Negative 2 minus 2 times 4. 3 times negative 2. Negative 6. Negative 2 times 4. Is that true? Negative 6 minus 8 is a negative 14. Is that less than or equal to 12?
Yeah.
Yep. So the first point is a solution. Okay?
I'm just confused. I'm not gonna lie.
This one is a solution.
You only have to do one of them if one solution.
What'd you say?
You only have to do one of them if you already got a solution for one of them.
Nope, you gotta check both.
Or
Yep, because it's basically asking you, is this first point a solution? And then is this second point a solution? So here, Zach, let's back up, okay? Let's erase. So what I'm going to do is I know that this is one problem and this is 2 problems, right? So for the first one, I'm going to put my point. And then I'm going to put this point over here.
No, I already got all that. I'm just confused how they're like this
Then I'm gonna write my equations. So x plus 4y is greater than or equal to 6, and 3x minus 2y is less than or equal to 12. And then I'm gonna write it again over here, because I know I gotta do it twice. You with me so far?
Yeah.
Okay, now I'm just gonna go and I'm gonna plug these in. Okay, so everywhere that I see an x, I'm gonna put -2, and everywhere where I see a y, I'm gonna put 4. Everything else is just gonna stay the same.
I already got all that. I wanna know how it is and isn't the solution. That's okay.
Is if it's a true statement, then it's gonna be
The
yes.
second point isn't.
Okay, so -2 plus 16 is greater than or equal to 6. We said yes, right? That works.
Yeah.
And then same thing down here. 3 times -2 minus 2 times 4. We said that was -6 minus 8. We know that's less than 12, so that one works too. This is a solution. This point. Now we just have to check the second point. So 3 is going to be x or y. And the 1 is going to be y. So now I just go and I plug them in. 3 plus 4 times 1. What's 3 plus 4? 7. Is 7 greater than or equal to 6? Yep. And then 3 times 3 minus 2 times 1. So this becomes 9 minus 2. Is 9 minus 2 less than or equal to 12?
Yeah.
Yep, so that one works. Now you get it? Okay, let's just get this done before lunch so we don't have to come back to it. Let's try this one.
All right.
Let's go fast. XY, right? In XY. So the first one, plug in this point to both. 3 minus 5 times -1 is greater than 10. Is that true?
No.
No? So 3 minus a -5 becomes 8 is greater than 10. Okay, so do I even need to check the point in the other one? Nope, because it doesn't work. Now let's try this point. Plug it in. 6 minus 5 times -3 is greater than 10. So 6 plus 15, is that greater than 10?
Yeah.
Yep. Now we'll plug it into the second one. 2 times what? 6 plus 3 times is greater than -2. 2 times 6. 3 times -3. Is that greater than -2? Yep. So that one works.
Second point.
So this one is a no, but 6 -3 is a yes. Make sense? Questions? Okay, if you have questions, make sure you ask them after lunch.